In this assignment, you are going to learn the last of the trig rules, or the derivative rules that you need to remember, and they would be formulas 1, 2, and 3 here for inverse sine, cosine, and tangent. I've listed the formula for the derivative of inverse secant. It will not be required that you memorize that for my tests, and I have not seen it appear on an AP exam, but it could be fair game. The derivatives of cosecant and secant we use very seldom, so I'm not even going to cover them here. All right, the important idea about the formulas, now that we know the chain rule so well, is we're going to recognize in our formula that u might not be a single variable x, it might be a function of x. So we require on each of these formulas, we've tacked on a chain rule for the glob u. So whatever is in the position here of u, we would have to do a chain rule on that glob. So you'll see that in action as we go through here. And there's a couple examples already done for you. You can come back to look at those. All right, so let's proceed right away. So we wanted to use the inverse cosine, and of course it is just like the formula for inverse sine, except it begins with a negative. So we want the opposite of 1 over the square root of 1 minus our u glob. There's our u glob, 3x. So our formula has a u squared. So let's make this a 9x squared. And then we do not forget the du dx. The chain rule on that glob would be a 3. So we can simply move that 3 into the numerator. And this is a final form. So for arc sine of 3x, the only difference is that it's positive. So we have 1 minus our u glob squared, and then our chain rule. So again, once you've practiced these, the chain rule, you can save yourself a step if you already think one step ahead and know that that 3 will be in the numerator. All right, let's try the formula for inverse tangent. And notice it has no square root. It is 1 over 1 plus u squared. Where these formulas come from, by the way, we're going to derive them. We're going to derive the derivative formulas at the end of this assignment. Okay, so here we've got our u glob. So the derivative of arc tangent is 1 over 1 plus that glob squared. Well, that's nice. The square root of x squared is just x. But then we can't forget our du dx chain rule. So the derivative of the square root of x, whether you write that as a power rule, 1/2 x to the negative 1/2, or whether you write it in this form, we've seen it many times. So I think a nice way to write this might be just like that. All right, so let's try the secant formula so that you've seen it. It's a little more complicated, so it's nice that that's not one that you have to worry too much about memorizing. 1 over the u glob is 3x times the square root of the u glob squared, 9x squared, minus 1, and then times our chain rule on the 3x, which would be a 3. So here that 3 would cancel with that 3. So we'll have 1 over x square root of 9x squared minus 1. All right, so if you can use that formula, I think you're fine. All right, our derivative of inverse sine is positive 1 over the square root of 1 minus our glob. Square root of x squared will be an x times, again, the derivative of that square root of x. And again, for sake of doing it different than last time, if you thought of it as the power rule, well, I would still then go right back to putting it as a square root of x in the denominator. And I think that's a perfectly acceptable form. But remember that you can multiply 2 square roots together if you saw an advantage to doing that. So you could put those 2 square roots back together by multiplication. So I think either one of those answers would work well. All right, here it looks like we have a binomial for our u value in the arctangent. Our derivative of arctangent is 1 over 1 plus u squared. So I could square that right away. But don't forget, if you start doing that, don't forget to do the chain rule on that binomial is a 3. And this one I should definitely clean up because I know there's going to be like terms. So this would be a minus 30x plus a 25. So these were the like terms that I think you should be expecting. So if there are like terms, especially in a multiple choice question, it would probably be given in this form so that the like terms could be put together. All right, so in number 7, our derivative of arc cosine, 1 minus the square root of 1, and then we want minus this glob squared, so that would be a 1/4 x, times the derivative of that glob would be a 1/2. All right, now I wanted this problem to appear because we don't like to have fractions inside of a fraction. And because 4 is a perfect square, we can see a very nice simple way that we can clean this up. And that is to do the following. I'm going to move this 2 over in front here. So much longer fraction line. I'm going to change this 1 into a 4 over 4. And the next time you see this, I think you would, oops, did I square it by the way? This should be our glob squared, so that x should have a 2 on it. So why would I like this? Because now I can factor a 1/4 out of this square root. So why would we do that? Because 1/4 is a perfect square. And that would simply leave the numerators left over. How it solved our problem of complexity is, what is the square root of 1/4? That square root is 1/2. So the 2 times the 1/2 would cancel out. So it works nicely. So we just came up with this as our final answer. So when did you do that? Whenever you have a fraction inside the denominator or numerator. So we don't care about rationalizing the square roots, but we do like to remove the complexity. So I did that simply by getting a common denominator. So the 1 turned into a 4 over 4, and then I factored 1/4. So that's sometimes one that students have trouble remembering to do, but it's really very simple algebra. All right, let's proceed. And here the argument of our arctangent, I notice, is going to require a chain rule. So I'm going to consider the x to be a u and the e to the x to be a v. So we're going to have to do a product rule as our chain rule. So let's see if that makes sense as we proceed. Get some more space to write here. F prime of x is equal to 1 over 1 plus our entire glob squared. So let's see, I want to square each part. So that would be x squared and e to the 2x. And then times the chain rule on this glob. And that's the thing I'm saying requires a product rule. So let me write it again up here a little bit larger. So I'm going to consider this my u term, this the v term, and the 2 I'm going to keep out of the product rule. So I'm going to do the u term x times the derivative of the v term. That would still be e to the x plus the v term, e to the x, times u prime. The derivative of the x term would just be 1. So we could factor an e to the x out of both of those. So let's move the 2 and the e to the x out in front in the numerator. And then wouldn't we have just an x plus 1 left inside? And I think that looks about as simple as we're going to come up with. So I think that would work for number 8. All right, we've got quite a bit to do on the back side of this worksheet, so I'm going to stop this video and do that in a part 2.